Okay, in this video we're going to test some logic gates that are simulated in the game of life. Okay, so we have a few logic gates saved here. So we have AND gate, we have OR gate, we have XOR gate, which is huge. Then we have NOR gate, we have the NOT gate, and I think that's it. Okay, so first let's add this circuit here, which is the glider replicator. So the neat thing about these circuits is that if we align them to where these markers are aligned with the 30 by 30 grid, then we can modularly add extra circuits. And as long as everything's aligned, the gliders are all in phase. So the gates function properly. Okay, so let's add this guy, and then let's add a glider generator. So this is a 60 period glider generator. So if we align it here, okay. So if you slow down, you see that the input gliders are in sync as well as the output gliders. So everything is aligned to this 30 by 30 grid. Okay, so let's first test the AND gate. AND gate. Okay, so now if we make sure that these markers are aligned, okay, so true and true should result in output true. Okay, so to interrupt the inputs, we are going to use a glider eater, this guy. So let's put it here first to test this path. Okay, so now this path is blocked, so this is true and false, which results in false. So now if we move this to the other side, okay, so once again we have false and true results in false, which is correct. And if we put blockers on both inputs, then okay, so now false and false results in false. So that's correct. Okay, so let's do another gate down here. Okay, so let's do another replicator here. Okay, let's add some space. Okay, make sure everything's aligned. Okay, that looks aligned. Okay, and now let's add another glider generator. This guy. So put it in the same spot here. Okay, that looks right. Okay, so now we're going to add a OR gate. Okay, and make sure that our markers are aligned. Okay, so now we have true or true, which results in output true. Okay. So now if we try to block the inputs, with this guy, okay, so blocking the first input. Okay, so now we have true or false, which results in true. So basically, both of these streams are interrupting this stream, right? So if we allow this stream to make it all the way through here, then it's going to annihilate this output. But let's test that. Let's go over here and block this side. Okay, so now this stream is blocking this stream. Okay, and of course if we add blockers on both sides, then of course this stream is going to make it all the way through. And now we have false or false results in output false. Okay, so now let's test the next simplest gate, which I guess, I don't know, NOR maybe? Yeah, because XOR is really huge, so let's do NOR first. Okay, let's do the replicator. Come on, replicator, this guy. Okay, let's put it here. Hopefully we have space. Okay, and then aligned the corners. That looks good. Okay, so now add, oh, did we miss it? No. Let's add a glider generator, so in the same spot here. Okay, that looks correct. Okay, so now let's get a NOR gate. XOR is really huge. Okay, NOR. Hopefully it fits. Okay, let's put it over here maybe. Okay, is that aligned? No. Okay, there we go. Now it's aligned. Okay, so now NOR, we have true, NOR, true, which results in output false. So we don't have anything on this side. So now let's try to add some blockers. Oh. Let's add this guy. Okay, so NOR gate isn't too bad. Okay, so there we go. We have true, or sorry, true NOR false gives us false. Is that right? Guess so. Okay, let's try the other side. Okay, so we have false NOR true gives us false. Okay, so now let's try blocking both sides. Okay, so if we block both sides, then we have false NOR false gives us true, which is just not of OR, I believe. Yeah, okay. So now let's do a big one. Let's do the XOR gate. So I'm gonna need some space for this one. Okay. Let me see how big it is. Oh, that's massive. Okay. Let me just see. Here? I don't want to have my streams interfere with the adjacent gates. Okay, that looks right. Okay, so let's just add this guy. Okay. And then let's add a replicator. Did I miss it? Yeah, okay, here. So let's add a replicator over here. Okay, that looks aligned. And now, fingers crossed, we're going to add a glider generator. And hopefully everything is aligned correctly. Okay, where did I put it here? Yeah, okay. Okay, is that right? Okay, so this one is going to take a while to update. Okay, so we have true XOR true, which I believe. Is that right? Does that give us false? Let me check. Yes, so XOR only gives 1 when the inputs are different. It gives 0 otherwise. Okay, so let's test the different inputs. Okay, so now if we block this input, then the output is 1. Well, let's wait for it to update. Okay, that's still 1. Okay, so let's try the other side. Okay. Okay, so now it's updated. So false XOR true gives us true. Okay, so now let's try to block both inputs. Okay, so now both inputs are blocked. Okay, so finally the output is false. Okay, so that's the XOR gate. And one last gate, which is the NOT gate. So let's see. This might be tricky. Nor not. Okay, well hopefully everything's is aligned. Okay. Okay, let's make sure the corners match. Okay, so right now the input is 0 and the output is 1. So let's try to add a glider generator. Okay, let's make sure it's in the right spot. Okay, so we put the glider generator in the same spot as the other gates, and as you can see, the glider phase matches what it's supposed to be for this gate. And so now true, not gives us false. Okay, well that's all the gates I got. And basically you can see some of the common elements here. So this is the NOT gate, and essentially NOR is just NOT of OR, right? So if we look at our OR gate, is that true? Let me see. Okay, well, maybe there's some simplification. Yeah, this is just a generator here. and we have two paths where the stream can be blocked. Right, so this is essentially a not gate, right? So this, not including the generator, but this part is the same as here. And this S shape is just to align the output glider with the grid. Okay, so yeah, I guess here's a better example. So this NOT gate is just at the end here. It's the same. Okay, well that's that. So we have the well-known gates simulated in the game of life. Okay.